Hello Python programmers! Today we're going to talk about nested lists and Numpy module for scientific computing. So first let me start with a few lists. I've got my list A with 3 different numbers, 1, 2, 3, and I've got my list B with 4, 5, 6. I can access individual items from the array by putting in an index, like give me the first item from A or the second item from A. I can look at the length of a list with len. But if I want to add matrix A to matrix B, I might think that I just use an addition sign, but what it ends up doing is concatenating those two lists together. So it doesn't actually do the matrix math. How would I do the matrix math? I've got a little PowerPoint slide with a couple solutions. So one thing we could do if we want to add the blue matrix to the other blue matrix and get the purple matrix as the result is we could set up these nested lists. So every row from our matrix is a list inside of another list. So we've got our first row here and our second row here, and we'll set up B and an empty matrix for our solutions. And every time we want to do some math, like 4 plus 1 is 5, we'll have a line like this saying the solution, we're going to put it in row 0, column 0 is whatever is in A, row 0, column 0, and B, row 0, column 0. And then we'll do that for 6 times so that we get the entire contents of the matrix. Well, it's not very efficient if you have a 20 by 20 matrix or something that involves a lot more numbers than we have here. Here's a little more efficient way to do it with nested for loops. We could say, I want to look at all the rows in range length of A. Well, the length of A is only 2. There's only 2 things in A. They're both lists, but there's only 2 of them. So there's 2 rows there. And for my next for loop nested inside there, I'm looking at the length of the very first item in the list, which is the 4, 5, 6. So there's 3 different columns in our matrix, so we'll get a 3 for our second range command. And if we go through this nested for loop, we only need one assignment statement, and we'll use those indices to figure out the row and the column, and then we get our resulting purple matrix right here. So this solution works and it's fine, but there is a better solution, or a solution that involves less lines of code, and that is using something called the Numpy module. So first we're going to import numpy as np, and this will allow me to use the alias np instead of typing out that whole word numpy. And so if I want to try things like, let's create a numpy array, np.array, and I want this to be a matrix, the first matrix in our math problem where we are adding 2 matrices together. And so we've got the nested list, but we're going to pass it all into a function array. And let's store the result in the variable matrix1. Well, what can we do with a numpy array? It's a lot like just a normal Python list. We can access the very first item by using square brackets and a number. So we can access the first item is a list of other numbers. And if we use 2 indices, we can say, well, give me just that number 4 out of that list 4, 5, 6. What else can we do? Well, let's set up another matrix. Matrix 2, that's also numpy array, and it's going to have the other numbers that I wanted to add together, 1, 0, 3 as the first row and 1, 2, 3 as the second row. And we can do the length of the matrix just like we did with the length of a list, but one thing that we can do that we couldn't do before is we can take matrix 1 and add it to matrix 2, and now it actually does that matrix addition that we wanted. It does the element by element addition, and we come out with this matrix in purple. So that's an improvement. That's something that wasn't as easy to do without the Numpy module. And let me show you something else that's not as easy when you don't have the Numpy module for scientific computing. Let's say you want to create a for loop, and you want it to go from 0 to 7 in increments of 0.25. And we know with the range command, we always stop before we hit that last number. That's why I made that 7.25, because we really want to stop at 7. Well, if I try to run this, I'm going to get an error message, because you can't have floating point numbers, things with decimal places, when you're using the range command. So we could change this, if we were to change this and say go from 0 to 8 in increments of 1, it works just fine. It's fine when we use whole numbers with the range command, but we can't use a floating point number, something with a decimal place. But we can do that with something in the Numpy module. So we've already got our Numpy module imported. We can say, I want to not use the normal range command, but I want to use a different version of the range command that the Numpy module has. So they call it a range. And I want to go from 0 to 7.25. Really, I want to stop at 7 in increments of 0.25. And oops, let's see, maybe I didn't import the Numpy module. Let's do numpy as np. And then try that same command. And in fact, I want to store the result in a variable in case I want to use that later. And now I do exactly what I wanted. I create this NumPy array that goes from 0 to 7 in increments of 0.25. What else can we do with the Numpy module? So a few other things you might want to do when you're doing matrix math is to set up matrices that have maybe all ones or all zeros, and that can be done with numpy ones. And then we need to put in the shape of the matrix. So if it's just 1 row and 3 columns, we could do something like that. What if it's a 3 by 4 matrix? And then we'll put in the dimensions, 3 rows, 4 columns. And there's also a numpy command that will create a matrix with all zeros. All right, thanks for watching this video.